add up to 11. Okay, so just take a look at that and see what you come up with, please.
Is it 8 and 3?
It is 8 and 3. So it would be x plus 8, x plus 3. Okay. Very good. So these are all of the problems we just did just now. These are what I call they're this what I call the case one. They're the plus plus case. If you noticed, all the answers were plus plus, and in the original problem it was plus plus. But there are others to consider. So we're just going to briefly review those now. I can't remember exactly how far we're going, but let's look at this next one here. Let's say it's x squared minus 10x plus 16. So this time you're looking for two numbers that multiply to 16. So you're like, okay, 1 times 16 works, 2 times 8 works, and 4 times 4 works. But when you add these up, they're all positive. And we don't want positive now, we want negative 10. So it's like, well, what do you do? Well, if they were both negative, negative 1 times negative 16, that's positive 16. Negative 2 times negative 8, positive 16. Negative 4, negative 4, positive 16. Now, do any of these add up to negative 10? And the answer is that yes, they do. Okay. So here in these set of examples, they're going to be both negative. Do you see the difference between the ones we were working on this new type of problem?
Mm-hmm.
Okay. So it's a relatively simple example here. X squared minus 4x plus 3. Again, it's like, okay, well, what numbers multiply to 3? And you're like, okay, it's 1 and 3. 1 and 3. But it needs to be negative 4. So negative 1 times negative 3, does that multiply to 3? Yes, it still multiplies to 3, but this time it adds up to negative 4. All
And
right.
if they're both negative numbers, you have to do the positive, and like, wouldn't you have to do like,
That's case
I don't know
3.
how to describe it.
Yeah,
Yeah.
that's coming up here. So I just wanted to do
Okay.
a couple of these with you to get ready for that. So now let's have you try and just give you a few more options here. X squared minus 12x plus 27. I'd like you to try this one for us, please, and see what you come up with for that.
Is it 9 and or negative 9, negative 3?
Yes, and the sign really matters, right? It's like going down a one-way street the wrong way. It can really be bad. So just I think the challenge, of course, is finding those numbers. Let's have you try one more here. Now I mentioned before the variables could be different. So like a squared minus 12a plus 32. All that changes is what goes in parentheses. It's going to be an A and an A. So just try one more here before we move to the more difficult type.
Is that a 12 too?
It is the multiplies to 32, but adds up to negative 12.
Okay, so 12. -4, -8.
Yes, very good. Okay. All right, now that's what I call case two. Okay, and the answers are both negative. Whereas case one, the answers were both positive. Okay, and they looked like this: x squared plus bx plus c, x squared minus bx plus c. Okay, but they really increase in difficulty from here, case 3 and case 4 here, because the answer is going to have one positive and one negative, or one negative and one positive. So we're going to look at those now. Just a little more effort on your part to be able to factor these. So let's jump right in here. So let's try an example here. X squared minus 13x minus 14. So this time the two numbers have to multiply to minus 14. This is what you were just asking me about. It's like, okay, it's 1 and minus 14, or it's -1 and 14. 2 and -7, -2 and 7. And this time they have to add up still to that middle number, but this time it's -13. Okay, so which in this list would do that?
Okay, it froze for a little bit there. It's back now.
Sorry,
All
so
right.
what is it? Just asking you, which in this list here add up to -13?
1 and -14.
Yes, very good. Okay, so I think what's hard for most students is that they don't want to write out they don't want to write out the complete list, and then they either say it doesn't have one, or they get the signs wrong, because it's very easy to mix them up here, between 1 and -14 and -1 and 14. So the challenge really is, like, can you be disciplined to come up with the entire list? Okay, now in this problem, we're looking for two numbers that multiply to -5 but add up to -4. Now the only factors of -5 are -1 and 5 and 1 and -5. And when there's only two, it's not too bad. You just say, oh, okay, well, -4, how do I get -4? Oh, it's the second one. Okay. It's recognizing that you have to write the entire list, alternating between positives and negatives. So here's one for you to try or think about. Go ahead and work that one out. Let me know what you come up with, please.
I'm finding clean paper. You used up this one. Here's one. All right. Is it 2 and -8?
Yes, yes, perfect. X plus 2, X minus 8. All right, good. So like one of the things, I think that I hear, from students, again, just mostly they get the signs wrong when they're doing something like this one. Um, the way to do it here, I mean, if you're looking for a shortcut, a bit of a shortcut. Sorry, I lost my place on my notes here. Let's say it's x squared minus 4x minus 45. If you write 45 and you start writing all the pairs, so like 3 and 15, 5 and 9, this one only has 3. They're to get to -4, they have to be 4 apart because the negative just takes the sign of one or the other. So that's somewhat of a shortcut here. I mean, I would still recommend writing the entire list, but you can see it's 5 and 9. But the question is it x minus 5, x plus 9, or is it x plus 5, x minus 9? And like from years of doing this, I mean, I see that the 5 and the minus 9 get you back to -4, but that's kind of up to you how you want to do this. If you want to write the full list, or if you want to try to guess and check a little bit on that. All right, so let me have you try one more before we move. Actually, that's good enough because the next one is the same type of case. So let's look at this one here. So this one's x squared plus 2x minus 15. So this time you need two numbers that multiply to -15, but add up to +2. So if you make that full list again, it's not that many, but we'll get them all in here. So this time it's adding up to a positive number instead of a negative number. It's still going to be the 3 and the 5, but is it -3 and 5 or 3 and -5? Well, you can see that it is because we want +2, that it is the -3 plus the 5.
Because that would just be 5 minus 3 technically.
Yep.
Or basically.
Exactly. Yeah. That's awesome. So notice that you have one positive and one negative in your answer. One positive, one negative in your answer. One positive, one negative in your answer. And so that's the challenge, is just to get the right order here of them. So let me have you try this one here. X squared plus 5x minus 50. You try that one for us, please.
D. So is it -5 and 10? Hello? I can't hear any.
Yeah,
Oh, there we
yes.
go. Okay,
Sorry about
sorry.
that. I muted myself because I was trying to find some other problems.
Oh, okay. I
Let
was
me
just hoping that it wasn't frozen again. Right.
no. All right, so maybe try one more and then we'll do some synthesis here. So let's say it's c squared plus 4c minus 12. Go ahead and try that one on your own, please. And let me know what you come up with.
Would it be -2 and +6?
Yes. C plus 6, C minus 2. Okay. Very good. All right. So the summary here is there's three cases, case 1, case 2, or type 1, type 2, type 3. So case 1 is x squared plus bx plus c. So think of it as the positive case, and your answer is x plus. The second case we did is x squared minus bx plus c, and your answers were x minus. Case 3 had two possibilities, x squared minus bx minus c, or x squared plus bx minus c. But the way that these worked is it was always an x minus x plus, or an x plus and an x minus. So this is the summary of what we've done, and now what I propose is giving you synthesis. So mixture of each. I'm sorry, mixture, not a synthesis. Mixture of each of these. So like, I'll just put up a problem and ask you, well, is it a case 1, a case 2, or case 3, or really all I care about is like, do you know how to form the answers? You know, is it both positive, both negative, one positive, one negative?
Okay.
So I don't know if you need to get this down. I mean, it's obviously in the notes, but we're going to refer back to this a couple of times here. So here is a new problem for you to try, because this is how it'll be on the, they're not going to say, oh, it's, it's the plus case. They're going to just say to factor. So you have to look at a problem and you have to be like, all right. And the problem I'm giving you is in this middle form right here. Like it's one of these. So what do you say? Is this where
Case 3.
so notice that it's minus and then plus. That matches with this case 2 here, minus and then plus.
Oh wait, I didn't see the second minus. I was reading that as a plus.
So this tells you the answers are both negative.
Oh no, wait, I was reading the third line, I think. Okay.
Yeah, so it's like I look at this as x squared minus bx plus c. And that's where it matches back with this second line. Okay, so could you factor this one for us? Two numbers that multiply to 15 but add to -8. They're both going to be negative in this example.
negative, -3, -5.
Yes, so x minus 3, x minus 5. Is that clear? Is that okay?
Mhm.
All right, so I'm just gonna move this down so we can see the next one here. Just snip that in. Yeah, here we go. Okay. So which of the cases is this one?
Case 4.
Right. And that means that you've got one positive and one negative. The order doesn't matter. Two numbers that multiply to -6 but add to +5.
I feel like that one's a pretty easy one. That would be -1 and 6,
Yes.
+6.
X plus 6, x minus 1. Yeah. And so, like, maybe I mean, I like hearing that it's easy. Keep in mind, I mean, I'm showing you the types right there. I mean, you wouldn't necessarily have this, but here's another one for you to look at. How are you doing on this one?
I'm just finding the multiples of it.
Okay.
+4 and +5.
Yes, you got it. X plus 5. Very good. Yeah. All right. So, like, I think the hardest thing is that now we're gonna move on to a different type of factoring altogether. And like, you're gonna get problems that have some of these, some of this other type, some of this other type that I'm gonna show you, and so on and so on. So it's a lot to sort of digest, but I mean, that's the 27-minute version of learning how to factor those types. So we're gonna move on to what are called perfect square trinomials. And you don't need to know the name, but that's that's the next category that we're moving into. And it's a problem like this: x squared plus 6x plus 9. And you might say, well, Matthew, that looks a lot like the ones we've already done. Like there's plus and plus, there's a 1 in front, and you would be right. These have, though, another form that the answer takes on, because the ones we're looking for here are 3 and 3. Okay, 3 times 3 is 9, 3 plus 3 is 6. This becomes x plus 3, x plus 3. So notice that the two numbers are the same this time. So another way that this could be written is x plus 3 squared. And that's because both of these are the same. All right. So that's an example. Here's another example. Let's say it's x squared plus 10x plus 25. Okay. The two numbers that multiply to 25 but add to 10, they're 5 and 5. So this becomes x plus 5, x plus 5, or x plus 5 squared. Any questions on that so far?
That makes sense, I think.
Okay. All right. So these are so far, these are what I call type
So,
ones. Go ahead.
no, actually, can you explain that again? What's with the exponents on it?
Okay, good. Yeah, good. That's good because this is different. So our answer is x plus 3 times x plus 3, but then it's x plus 3 squared. It's analogous to let's say it's like u times u, that's u squared, or x times x, that becomes x squared. So since the bases are the same, there's really an exponent of 1 and 1, and that's what leads to the 2. 1 plus 1 equals the 2. Same thing down here. The exponents are the same, so or the bases are the same, so when you multiply, you add the exponents. 1 plus 1 is 2. Now, if you go back and look at the previous problems we did, and we're going to scroll back up here for a moment. The previous problems, like none of the numbers were the same. 6, -1, 3, -5, they were never the same. 4 and 5. And I didn't say it, I didn't know if you would notice, but they're never the same. They were never, ever, ever the same.
Do they ever become the same?
Well, that's what we're looking at now with the perfect square trinomials. They are the same in these perfect square trinomials. Okay, so we'll
Oh
just
wait,
do,
you mean the bottom numbers? Okay,
yes,
not
yes.
like the. It would never be like some
Well,
the numbers in the. I don't know.
here, I think I know what you're referring to. I was about to give you this one. This
So
is,
it could be like that.
it could be like that. This is the only one, but this is like what you're asking about is kind of an interesting problem. It's where the perimeter and the area are the same. And in a square, the
Oh, so 4 and 4.
well, you would think like this there is one though, and it's 4, 4, 4, and 4, 4 and 4. That gets you to 16 and 16 for perimeter and area. But it's a good question to ask. 4 has factors 2 and 2. Those add up to this 4 on the left. So it's x plus 2,
Mm,
x plus 2. Okay, and then you would write your answer as x plus 2 squared.
okay, so 4 is the only number that can do that. That's amazing.
Yes, yes. So you
Okay.
see, but it's a good question because these things. So it really comes down to like, do you remember your squares and square roots? And like here's one for you to try: x squared plus 8x plus 16.
Okay, so it's 4 and 4.
Yes, x plus 4, x plus 4. So after a while, and that whole square and square root, what you eventually notice is that, go back to the beginning problem, the square root of 9 is 3. See where we came up with that number? The square root of 25 is 5. The square root of 4 is 2. So there's a 2 in our answers. Square root of 16 is 4.
So would you always be finding the square root with these?
Yes. Yes. And that's why they're called perfect square trinomials. Okay. So the next example here would be something like x squared
But only
plus.
only these ones. Those other ones didn't give us the square of the
That's right.
numbers, right? Okay,
That's
it's
right.
only the ones where both of the numbers on the bottom are the same.
Yes. Yes. Okay. So this one, my question to you is, can you take the square root of 81? Or do you know the square root of 81?
Mm-mm.
So this,
I
so
got to
this
fast
is,
it out.
so this is where, just on your own time, squares and square roots would be good for you to get faster at.
I don't remember anything about square roots.
Yeah, so the idea here is that 9 times 9 is 81. Okay, so because the answer here is now x plus 9, x plus 9.
Okay.
So here's one for you to try: x squared plus 20x plus 100. Do you know the square root of 100?
Is it 10?
It is 10. Yeah. So what does this become? What is the answer down here?
That would be x plus 10 times x plus 10.
Yeah, or x plus 10 squared.
Like,
Okay. So let me just drop in the chat a link to so on my website, I put up squares and square roots reference sheet. You might look at that, print it out, or just look at it. So again, like kind of like everything else in math, like once you feel like you've gotten this down, then I throw something different at you. So what we just looked at is case one, and it's x squared plus bx plus c, but the c is a perfect square. All right. The case two is where I just change one sign, minus bx plus c, but again, c is a perfect square. So some of these examples are going to look really similar. It would be x squared minus 4x plus 4. So again, it's like, well, can you take the square of the last number? And yes, I can. It's 2. Okay. But notice it has to be minus 4 this time. So the answer ends up being x minus 2, x minus 2.
well, that wouldn't be the square of 4 still, would it?
It is, it's just a different form. So like
Oh, okay. So it
the early,
still is.
yeah, it still is. You just have to pay attention to the sign, which is, obviously very important. So we did this problem on the right earlier, and it was x plus 2, x plus 2. And there's only 2 cases here, so you don't have to get you don't have to get too overwhelmed by this, but you still look at that last number. Can you take the square root of it? Can you take the square root of it? And the 2 and the 2 are the same. It's just one is, on the left here, they're both negative. On the right, they're both
Yeah. So it would be like the square root of -4.
that's different. That's a different thing altogether.
Oh.
But it's the answer. What it really is there's 2 solutions to the square root.
Oh, okay.
It's plus or minus, and that's sort of hidden from you while doing this. Okay, so again, here's another example here: x squared minus 16x plus 64. So you can take the square root of 64. Can you tell me what that is?
I have to figure it out.
Okay, so they give you that here. It's the plus or minus 8.
That would be -8.
Right, so it's x minus 8, x minus 8, like this. And then, again, similarly, it's like x squared plus 16x plus 64 becomes x plus 8, x plus 8, like that. Okay, so here's one for you to try: x squared minus 12x plus 36. You could try that for us, please.
Mhm. Oh, it's -6 and -6.
That's correct. Yes.
I was
Awesome.
waiting until I got one that was it like itself.
Yes. That's great. Yeah. I mean, it's really key that you be able to do this. So
It's almost a little easier because it's like, okay, I know when to when to stop now because it's like, oh, once it's the or well, kind of like around where to stop. Yeah.
yes. Yes. Okay. So we'll give you one more here of these before we change the difficulties. Let's try this one. Let's go. I'll just change the variable m squared minus 10m plus 25.
So it would be -5.
Yes, m minus 5, m minus 5, or it could be m minus 5 squared like that. All right, and just the moment you feel like, hey, I've got it, this is no big deal, I give you a new type of problem. So let's look at 4x squared plus 12x plus 9. And this is also a perfect square trinomial. So this one's a little bit different. You have to actually take the square root of two things. You have to take the square root of 4x squared, or you can think of it as just the square root of 4. And then you have to take the square root of 9. Okay, so this one's a little bit more involved. We haven't really talked about the square root of 4x squared, but just think of it as the square root of 4, which is 2, and the square root of 9, which is 3. So let me write your answers here: 2x plus 3, 2x minus 3. I'm sorry, 2x plus 3. I'm sorry, I really miswrote that. I was thinking something else. 2x plus 3 times 2x plus 3. So the 2, well, let's talk about the 3. The 3 comes from the same place it's always come from that last number there. Okay. Now, instead of x and x, we write 2x, and that comes from this 4 in front. Okay, so you have to just do a little bit more work this time. You have to actually find the square root of the first and the square root of the last. Okay, and again, you could write your answer as 2x plus 3 squared. So let's look at another one here. Another example here. Let's say it's 4x squared plus 20x plus 25. Very similar to the last problem. Can you take the square root of 4, that first term? Yes, that's 2. Can you take the square root of 25? Yes, that's 5. So this becomes 2x and 2x. That's coming from this square root of 4, the 2. And then the 5 tells you that it's plus 5 plus 5. Or 2x plus 5 squared.
But we have to worry about finding the square root of that middle number. Just
No, ignore the middle
Okay.
number altogether. Ignore the middle number altogether. Okay.
So
All
when
right.
there's one that has 3 like that, you just how does that work?
Well, I'm telling you what this is. You don't have to think real hard about the type, but what I want you to look for is, can I take the square root of the first number? Can you take the square root of the last number? So let me give you another example here. Probably need more examples of this type. 9x squared plus 6x plus 1. Can you take the square root of 9? That's the first number.
The 3?
Yes. And then can you take the square root of 1?
Does 1 have a square root?
It's 1.
Okay.
Yes. So that tells you how to write the answer. Okay. 3x, that takes care of the first one. And the 1 here is plus 1 plus 1.
And does that do the same thing where it ends up adding to that middle number? Or is that middle number just like,
It does not. That's kind of different.
okay. But it's always going to be the square root of both of those numbers?
If it's a perfect square trinomial, yes.
What if it's not?
Well, so there's 5 different types of factoring. So so GCF is the first type of factoring. The second one is called difference of squares. The third one is perfect square trinomial. The fourth one is this A equals 1. So and then the fifth one is grouping, which we'll get to. But like these are the easiest to explain, I think. So we're just moving through the different types of factoring. To try not to get too overwhelmed. I mean, you're doing like 2 weeks of work in 45 minutes so far. And there's a lot here in a typical classroom. Okay, so let me give you some more to look at, think about, and again, they're all the same type. So it's not like I'm going to mix them up and say, oh, here you go, here's a new type. Sorry, plus ADX. So can you take the square root of 100? Can you take the square root of 16?
It'd be 10 and I'm not sure what it is for 16 again. I think I just did it.
Yeah, 4. Square root.
Okay, yeah.
4. So this becomes 10x and 10x plus 4 plus 4. Do you see where those numbers come from? The 10, 10x?
Yeah, it's the square roots of those first and last numbers, if you can take the square roots from them.
Yes. So here's one for you to try. Let's go 9x squared plus 30x plus 25.
So that would be 3x plus 5.
Okay. What about the other one?
Oh, so 3x plus 5.
Very good. Let me see if I can find different one. I guess we don't have this. Okay, let me make up one here for you to try. 64x squared. 64x squared. Sorry, I just got to do a little mental math here.
I have to run to the bathroom real fast.
Okay.
I'll be back in a minute.
Okay.
All right, I'm back.
Okay,
Let's see.
so can you take
So-
the square root of 64? Can you take the square root of 49?
Let's see. 64.
So square root of 64 is 8. Square root of 49 is 7.
Oh, I
What-
was trying
What would go in parentheses?
to. It would be. 8x plus 7, and then another 8x plus 7. And
Good.
then
And then you
would it
could,
end up being, 8x plus 7 squared?
yes,
Or, yeah.
same thing with the previous problem here. Good. Okay, well, that does take us to the end of our lesson for today. So lots and lots of problems that we worked on. If you have some time, definitely recommend reviewing them. But this Thursday, we'll just keep going through factoring.
Okay.
You know, another couple of types, and then we can do the more complicated division problems. But good job today. It's a lot to take on such a short amount of time, which you did great. But that is it. I hope you enjoy the rest of your day or can get some sleep. But I'll
Thank you so much for scheduling me in, by
yeah,
the
you're
way. I'm
yeah, you're
sorry,
welcome.
missing the last
We're
one.
all good. All right. I'll talk to you on Thursday. Have a good night.
All
Good
right,
day.
see you
Bye.
Thursday. Thank you.